Good morning, students. In the previous videos, we have finished the 3A exercise, and in this today's session, we will be discussing the stuff which is necessary to do the 3B exercise. So, in this session, we will be discussing the various things like equation of a tangent to the parabola, equation of the normal to the parabola, equation of the chord of contact, and equation of the chord joining the 2 points. So, and at both at Cartesian points and parametric points, all the stuff that we have learned in circles, we will be discussing the same in this chapter also. So, first of all, equation of a chord joining 2 points of a parabola is S1 plus S2 is equals to S12. So remember, the same thing we have discussed in the circles also. So for example, this is a parabola, and let us suppose that P comma Q are the 2 points on the parabola, and this parabola be, for example, y square equals to 4ax, p x1 y1 and q x2 y2. So consider this equation. Consider s1 plus s2 equals to s12. So what are the notations of this parabola? Y square equals to 4ax, or y square minus 4ax is our S parabola. S1 is y1 minus 2a into x plus x1. S2 is y2 minus 2a into x plus x2. S11 is y1 square minus 4a x1. Simply substituting x1 y1 point in the parabola, then we will be getting this. And S22 is y2 square minus 4a x2. S12, which is equal to S21, which is y1 y2 minus 2a into x1 plus x2. So these are the notations in the parabola. Now, if you consider S1 plus S2 equals to S12, so what is S1 here? y1 minus 2a into x plus x1 plus S2 is y2 minus 2a into x plus x2 is equals to y1 y2 minus 2a into x1 plus x2 minus 2a into x1 plus x2. This is equals to, now substituting x1 y1 in this equation, let us see what will happen. So, how do we substitute? In the place of y1 to be substituted, in the place of x, x1 is to be substituted. In the same way, now here y1 square minus 2a into x1 plus x1, 2a x1, 2x1 plus y1 y2 minus 2a into x1 plus x2 is equals to y1 y2. So this is y1 y2 minus 2a into x1 plus x2. This is equals to y1 square minus 2 to the 4a x1 plus y1 y2 minus 2a into x1 plus x2 is equals to y1 y2 minus 2a into x1 plus x2. So this is equals to, what is y1 square minus 4a x1? This is the notation of s1. This is the notation of s1 plus, what is this? y1 y2 minus 2a into x1 plus x2. This is s12 is equals to y1 square minus 4a x1 is s11. This is the notation for s11, right? So this is s12. So here s11 equals to 0, which is true. We got s11 equals to 0. That means s is y square minus 4ax. s11 is y1 square minus 4ax1. And this s11 is equals to 0 we get, since, which is true, since px1 y1 lies on the parabola, s is equals to 0. In the same way, substituting x2 y2 next, substituting x2 y2 in this one, let us see what will happen. So y, I'm rubbing this, and now this is equals to, in the place of y, y2 is to be substituted, in the place of x, x2 is to be substituted. Then y2 y1 minus 2a into x2 plus x1 plus, this is y2 into y2 square minus 2a into, this is in the place of x, x2 plus x2, 2x2, 2 2s are 4a x2 is this totally, is equals to, this is y1 y2 minus 2a into x1 plus x2. So this is equals to, what is y2 y1 minus 2a into x2 plus x1? This is s21 plus, this is y2 square minus 4x2 is s22 is equals to, what is this? s12. So we know that s12 is equal to s21. So this is, this gets cancelled. Therefore s22 is equals to 0, which is again true, since qx2 y2 lies on the parabola s is equals to 0. So the intention behind doing all these things is just to say that px1 y1 lies on the parabola and qx2 y2 lies on the parabola. That's it. And if you see here, this is y1, this is minus 2ax. On expansion, minus 2ax1 is what we will be getting here. Here, minus 2ax2. Here, minus 2ax1, minus 2ax2. That means these are getting cancelled. And what more that we are left here is that here y1. So here y1, here y2. So y of y1 plus y2. y1 plus y2. Y if you take common, y1 plus y2. So here minus 2ax. Here minus 2ax, minus 2ax. So minus 4ax is equals to, this is y1, y2. So if you see here, this is seemed to be the first degree equation. So here y, here x, and this is constant. So this is the first degree equation. Hence it means this line, it represents the straight line equation. This represents the straight line. Therefore, S1 plus S2 is equals to S12 that represents the equation of a chord joining the points Px1 y1 and Qx2 y2. So in the next session, we will be discussing the equation of the tangent to the parabola. So the limiting point concept that we have discussed earlier in circles, in the same way, we will be discussing here also. Now let us see the equation of the tangent to the parabola. So earlier, this PQ is a chord. This PQ is a chord. Now, this PQ is now a secant line, right? The infinite line. This PQ is a secant line. This secant line PQ approaches to the same limiting position as Q moves along the curve and approaches to P from either side. So this is the chord. So actually, if you keep on moving this, this line, so this line, if you keep next time, so this is P, this is Q. So this time it will be this, and again if you move, it will be this, and again you move until actually this chord becomes a tangent to this parabola. So that is what the limiting position, which we have discussed earlier in the circles chapter as well. So, and approaches to P from either side, then the limiting position is called a tangent line. Now, see this, earlier the chord is this. As we keep on moving this chord, so the chord length is minimized here. Here, it is further minimized. And to the extent that until this chord becomes the tangent. So, actually, what is the equation of the chord joining the 2 points? S1 plus S2 is equals to S12. As limit Q is tending to P, S1 plus S2 equals to S12. That is P x1 y1 and Q x2 y2. So if Q keeps on moving, then Q is equals to P. That means x2 y2 is equals to x1 y1. So that means S1 plus S2 also S1. S1 is equals to S1. This 2 also becomes 1. So this is equals to S1 plus S1 is 2. S1 is equals to S1 1. Now since P x1 y1 lies on a parabola, that means y1 square minus 4ax1 is equals to 0, because parabola S is y square minus 4ax is equals to 0. So since x1 y1 point lies on the parabola, y1 square minus 4x1 equals to 0. So this would be how much? 2s1 equals to 0. Therefore, s1 equals to 0. Therefore, equation of the tangent to the parabola at the point P x1 y1. That means this Q is tending to P until this chord PQ becomes the tangent to the parabola. That means this. So this is P. So this is x1 y1 and the parabola here is s is equals to 0. Therefore, the equation of the tangent to the parabola is s1 equals to 0. What is s1 equals to 0? y1 square minus 4ax1 is equals to 0. Another proof to find out the equation of the tangent to the parabola s is equals to 0 at p x1 by 1 is s1 equals to 0. Let this be parabola s y square minus 4ax. So here, and this is the point p x1 y1. This point is p x1 y1. So slope slope of the parabola y square equals to 4ax can be find out through differentiating. So here is differentiating with respect to x. We get, so y square derivative is, let us suppose y to be x. X square derivative is 2x. So here 2y into, since y is taken to be x, later with respect y with respect to x is to be done. So this is dy by dx. Remember, actually the last year calculus we have learned. So the slope of a tangent is nothing but finding the derivative at that particular point. So this is 2 dy by dx equals to 4a into dy by dx of x is 1. This is equals to dy by dx is equals to 2a by, this is y. Now, so dy by dx at point P x1 y1, at point P x1 y1 is equals to how much? 2a by y1. So this is our slope. So we have a slope and this line slope we have m and the point is also there. Therefore, equation of a line that is a tangent here, tangent passing through P x1 y1 and having slope m is y minus y1 is equals to m into x minus x1, slope point form. So this is equals to y minus y1 is equals to m is 2a by y1 into x minus x1. So this is equals to y by 1 minus y1 square. And one thing you bear in mind that p x1 y1 here, p x1 y1 lies on parabola. That means p x1 y1 when it is substituted in this, then it has to get satisfied. So that means y1 square minus 4a x1. So this is the parabola y square equals to 4x, and p x1 y1, since this point lies on the parabola, this point has to satisfy the parabolic equation. So y1 square minus 4x1 equals to 0. Now this is equals to, you bear that thing in mind. So here y1 minus y1 square is equals to 2ax minus 2ax1. So this is equals to y1 minus, so y1 square is equals to how much here? y1 square is equals to 4ax1, because px1 y1 lies on a parabola. So point has to satisfy the equation of a line. So from which y1 square equals to 4ax1 we get. So in the place of y1 square, substitute 4ax1 is equals to 2ax minus 2ax1. This is equals to y1 minus y1 is equals to 2ax. This minus 4x1 on transposing onto another side, this is plus 4x1 minus 2ax1, which is plus 2ax1. So this is equals to y1 is equals to 2a into x plus x1. So what is this notation? Therefore y1 minus 2a into x plus x1 equals to 0. So what is this notation? So this is S1 equals to 0. Therefore, equation of the, so what is this? The equation of the tangent to the parabola y square equals to 4x at px1 comma y1 is s1 equals to 0. So this is what we have proved. Now the normal. So what is meant by normal, which we have studied before also in the chapter circle. So for example, let s is equals to 0 be the parabola. Let s is equals to 0 be the parabola, and this is a okay. So this is the tangent and this P is the point 1. So the line which is passing through P, the line which is passing through P. So this line is clearly passing through P and perpendicular to the tangent. This line is passing through P, which is the point of contact of the line and the parabola. So this is the point of contact, right? So this line is passing through the point of contact of s equals to 0 and the tangent. And not only that, it is passing through P, but also this line is perpendicular to the tangent. What is this? This is the tangent. This is the tangent. And what is this? This is our normal. So the line which is passing through P x1 y1 and perpendicular to the tangent of s is equals to 0 is called normal. So now the equation of the normal at px1 comma y1 is y minus y1 is equals to earlier 2a by y1 is what we got as the slope of a tangent at px1 y1. So 2a by y1, what is the tangent slope? 2a by y1. Just before we have found this also. Just now we have proved this 2a by y1 for the slope of the tangent. And what is the slope of a normal? So that is minus y1 by 2a into x minus x1. Since slope of a since the tangent or normal are perpendicular to each other, if 2a by y1 is the slope of a tangent, its perpendicular slope, which is 2a by y1, you just reverse it and change the sign. Therefore, equation of the normal at px1 y1 is y minus y1 equals to minus y1 by 2a into x minus x1. Let us discuss the point of intersection of a parabola and a line. So this s is y square minus 4ax equals to 0, and the line is y is equals to mx plus c. The line is y is equals to mx plus c. This line is y is equals to mx plus c. The point of intersection of this line and the parabola we get through solving these two equations. So here y is equals to mx plus c, substituting y equals to, here this is point of intersection of the parabola y square equals to 4ax and the line y is equals to mx plus c. So y is equals to mx plus c, substituting y in y square equals to 4ax we get what is y? Mx plus c whole square is equals to 4ax. This is equals to a plus b whole square, a square m square x square plus c square plus 2mcx is equals to 4ax. This is equals to m square x square plus 2x this plus 4x if you bring to this side is equals to 0. If you take 2x as a common, then we are left with here mc minus mc minus 2a plus c square is equals to 0. So this is clearly a quadratic equation. This is clearly a quadratic equation. So x square, x and the constant. This is a quadratic equation in x and its roots will be get through the discriminant delta equals delta. What is delta? E square minus 4ac. If b square minus 4ac is greater than 0, then it has two roots. That means the line cuts the parabola at the 2 points. In the same way, if b square minus 4ac is equals to 0, then the line touches the parabola. This time, this line, it will touches the parabola. When? If b square minus 4ac equals to 0. So, what is b square here? So, x coefficient is b. So, 2 into mc minus 2a. This is b square minus 4ac. A is m square. C is c square. So, this is equals to 0. So, this is 2 2s are 4. This is m square c square plus this is 2a whole square 4a square minus 2 2s are this is 2 into mc into 2a. 2 into mc into 2a. 2 2s are 4 mca minus 4m square c square equals to 0. This 4m square c square, 4m square c square gets cancelled. So take 4a square, 4a in common. Then we will be getting here a minus 4a if you take common. We will be getting here mc equals to 0. So 4a equals to 0. From this a equals to mc. From this c is equals to a by m. So c is equals to a by m is the condition that the line y is equals to mx plus c is a tangent to the parabola. And the third condition b square minus 4ac less than 0, then the line do not cut the parabola. In this case, third one, if b square minus 4ac less than 0, then line does not intersects the parabola. That means the parabola is this and this line is like this, the last condition. Let us deduce the condition that the line y is equals to mx plus c to be a tangent to the parabola y square equals to 4ax. So, theorem, the condition that the line y is equals to mx plus c to be a tangent to the parabola is c is equals to a by n. So the point of contact is a by m square comma 2a by m, and the equation of a line in slope form of the tangent. Equation of the tangent in its slope form is y is equals to mx plus a by m. So let us deduce this conditions. So let y square equals to 4x, parabolize this. This is y square equals to 4ax parabola, and this is the point of contact of both Px1 y1 is the point of contact of this line. What is this line? Y equals to mx plus c and the parabola. So what is this point? Px1 y1. Now, so proof. What is the equation of a tangent at Px1 y1 to the parabola s equals to 0? That is s1 equals to 0, which we have proved it also. So this is y1 minus 2a into x plus x1 equals to 0. Now, according to the, what is this y1 minus 2a into x plus x1, this line, this equation of this line. So according to the question, y is equals to mx plus c itself is a tangent. According to the given, y equals to mx plus c is a tangent. So that means y minus mx minus c equals to 0. This is second equation. So 1 and 2 represents same straight lines. 1 and 2 represent same straight lines. So now comparing coefficients, we get here minus 2ax, the x coefficient is minus 2a, minus 2ax, x coefficient is minus 2a. Here x coefficient is minus m is equals to, what is the quotient of y? y1. Here what is the quotient of y here? It is 1, is equals to, what is the constant? Minus 2a x1 itself is the constant. Minus 2a x1 itself is the constant. Here it is minus c. So that is 2a by m. 2a by m is equals to 2a x1 by c. So 2a gets cancelled. So x1 is equals to c by m, and this is 2a by m is equals to y1. Now since this P lies on the line as well as parabola also, since Px1 y1 lies on the line y is equals to mx plus c, since point lies on a line, point has to satisfy the line equation. So that implies y1 is equals to mx1 plus c. So what is y1 that we got right now? y1 is 2a by m is equals to m into what is x1? c by m plus c. So this is m gets cancelled. 2a by m is equals to c plus c is 2c. 2 gets cancelled. Therefore, c is equals to a by m. c is equals to a by m. This is the condition for the line y is equals to mx plus c to be a tangent to the parabola. And now, if you substitute x1 is equals to here, c by m. c is equals to how much? a by m by m. So a by m square, comma, y1 is 2a by m. So what is this point of contact? This point of contact P x1 y1 is a by m square, comma, 2a by m. And what is the equation of this line? This line is y is equals to mx plus c. So y is, since this line is what? Y is equals to mx plus c. So y is equals to mx plus, what is c that we got here? c is equal to a by m. So this line is what? Y is equals to mx plus a by m. So the condition that the line y is equals to mx plus c to be a tangent to the parabola y square equals to 4x at point P x1 y1 is c is equals to a by m. That is the condition. A by m square comma 2a by m. That is the point of contact of a line y equals to mx plus c and the parabola y square equals to 4x. And the equation of the tangent in its slope form is y is equals to mx plus a by m. Now, the equation of the tangent to the parabola y square equals to 4x in its slope form is y is equals to mx plus a by m. How do we get this? Y is equals to mx plus c. c is equals to a by m is the slope form of the tangent to the parabola s equals to 0. In the same way, the slope form of the normal to the parabola at the P x1 comma y1 is y is equals to mx minus 2am minus am cube. So let us reduce this. So proof. So y square equals to 4ax. For the parabola y square equals to 4ax. Slope is equals to how much? dy by dx equals to 2a by y at P x1 y1 is 2a by y at P x1 y1 is 2a by y1. So this is the slope of the tangent. This is the slope of the tangent. What is the slope of the normal then? Slope form of the normal is minus y1 by 2a. So now, since x1 y1 lies on the parabola, then y1 square is equals to 4ax1. So slope of the normal is minus y1 by 2a. This is equals to how much? M. So from this, y1 is equals to 2am. So minus 2am. So substituting y1 is equals to minus 2am in this. Substituting y1, we get, what is y1 that we got earlier? Minus 2am whole square is equals to 4ax1. This is equals to minus 2am whole square is 4a square m square is equals to 4a x1. So here 4a gets cancelled. Therefore, this is x1 is equals to am square. Therefore, we get px1 y1 to be how much? Am square comma minus 2am. Now we are trying to find out the equation of the normal. That means the parabola is this. This is our tangent. This is our tangent. And this is our normal. This is our normal at px1 y1. Right? So therefore, equation of the normal's slope is what? Normal slope is minus y1 by 2a, right? So equation of the normal having slope m equals to minus y1 by 2a and passing through the point am square comma minus 2am is the slope point formula, right? Slope and point formula. So this is equals to y minus y1 is equals to m into x minus x1. So this is equals to y minus y1 is minus of minus plus 2am is equals to m into x minus x1. So here m I'm not converting it into minus y1 by 2a, I am leaving it intact. Into x minus x1 is x minus am square. So this is equals to y plus 2am is equals to mx minus am cube. Therefore, the answer is y is equals to mx minus 2am minus am cube is the slope form of the normal in M. Now we will be discussing the equation of the tangent and normal at the parametric point. What is the parametric point for y square equals to 4ax? 80 square comma 280. So equation of a tangent at equation of the tangent comma normal at the parametric point. (80 square comma 280 to the parabola y square equals to 4ax. This is our main heading. So equation of the tangent at the parametric point. So 80 square comma 280 is y is equals to x plus 80 square, and equation of the normal at the parametric point 80 square comma 280 is y plus xt is equals to 280 plus 80 cube. So let us see this now. What is the equation of tangent at px1 y1 to the parabola S y square minus 4a is equals to 0? That is S1 equals to 0, right? S1 equals to 0. What is S1? y1 minus 2a into x plus x1. So what is y1? 280. minus 2a into x plus x1 is equals to 0. X plus x1. So x plus x1 is here 8 square. X plus 8 square is equals to 0. This is 2aty is equals to 2ax plus 8 square. So 2a gets cancelled. So this is y is equals to x by t plus a t square by t. So t gets cancelled. So what is the slope here? If you compare this with the y is equals to mx plus c, m is 1 by t. So this m equals to 1 by t is the slope of the tangent, right? So now from this, if you take the LCM, then x plus a t into t square is equals to this t when it is transposed, cross multiplied with y. So yt is equals to x plus at square. This is the equation of the tangent at this parametric point. Now, equation of normal is so m equals to 1 by t is the slope of a tangent. What is the slope of a normal? Slope of normal is m equals to minus t, because 1 by t into minus t is equals to minus 1. Tangent and normal are perpendicular to each other. The product of their slope is minus 1. Now, therefore, equation of normal passing through. So because there, so far, this tangent we have found at this point of contact. This tangent is this at the parametric point at square comma 2at. Now the normal now. So normal also passing through P. That's why normal passing through P. What is P here? The parametric point at square comma 2at. And slope m equals to how much? Minus t is, so y minus y1 is 2at is equals to m is minus t into x minus x1 is at square. So this is equals to y is equals to minus xt. So minus xt if you bring here plus xt. Y plus xt is equals to this minus 280 if you transpose onto another side plus 280. This is minus t into minus 80 square plus 80 cube. So that is this y plus xt equals to 280 plus 80 cube is the equation of the normal at the parametric point.